Hello everyone, today let's solve the problem number 43, multiply strings. So what the question states here, we are given two non-negative integers, you can clearly see here, num1 and num2. This is non-negative integers, once they have given positive integers. We are provided with positive integers, right, num1 and num2 as strings. This one we have to keep in mind. We are given two non-negative integers, num1 and num2 as strings. Our main task is to multiply these two numbers and return the result as a string. We need to return the result of these two numbers in the form of string itself. So we cannot use built-in big integer libraries. So this is very important. They have clearly mentioned we cannot use built-in big integer libraries or convert the inputs into the integer directly, or we cannot convert the input to the integer directly, right? So that's what. So here in this case, let's go with the first example. So here input num1 equals 2 they have given, and num2 they have given 3 here. The output here in this case is 6, right? So the output in this case here is 6, and here they have given num1 1 2 3 and num2 4 5 6. The output they have given here is 5 6 0 8 8 in this case, right? So when we multiply these two 1 2 3 and 4 5 6, we have to get this one 5 6 0 8 8, and we need to return this one in the form of string. Same goes with the example 1 as well, right? 2 into 3, we need to return this one in the form of string, that is nothing but 6, right? So I hope this is completely clear. So next what we will do here, let's discuss the approach first, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. First, initially what we'll do, let's discuss the approach. So here we'll be going with the digit by digit multiplication. So one thing, keep this in mind, we'll be going with the digit by digit multiplication or school book method. Here we'll be going with the school book method or the digit by digit multiplication, right? So just keep this in mind. I have considered the second example that they have given in the question, 1 2 3 4 5 6, so that it will be easier to understand, right? So let's discuss this one step by step. First step, what we will be doing, we will create a DP array of size num1 dot length, length of the num1 and length of the num2. In this case we have 1 2 3 and 4 5 6. This one length is 3 and this length is 3, you can clearly see here. So 3 plus 3 here is 6 in this case. So we will initialize 6 zeros within the DP table initially. So 6, we have the length 6, so we will be initializing here 6 zeros, 1 2 3 4 5 6, 6 zeros, right, within the DP. So the next step here is we will iterate through the num1 and num2 from right to left. You just keep this in mind, we are iterating from right to left, right? So this one we have to keep in mind. The final step here is we have to multiply the digits and store the result at the correct positions in DP. We have to multiply the digits and store the result at the current positions in DP. So here multiplication steps. Let's go with the multiplication steps here. So the first this one here is first step here is we'll be going with, this one is I, this one is J, this one is I into J or num1 into num2, this one is stored DP index or DP index, this one is result DP. So here you can clearly see we are going with 1 into 4. I'll just go with the calculation, you can just pause and look into the calculation, right? So first one is I into J, so this one will be 1 into 5 5, 1 into 6 6, so then we are considering 3 here, 3 into 4, 3 into 5, 3 into 6, and then finally here 2 into 4, 2 into 5, and this is just 2 because we are considering index 2 here in this case. So this is for the J. So here again 2 plus 4 equals 6, 9 plus 4 equals 5. This is for the DP of 4 as well as the this one DP of 4 as well as first one. Let's go with the first one here. This is DP of 1. This one, right? 2 plus 4 equals 6. So next one DP of 2 will be 9 plus 5 equals 14. DP of 1 equals DP of 1 plus 1, in this case 9 plus 5 14. So in this case DP of 3 will be 9 plus 6 equals 15. DP of 2 equals DP of 2 plus 1 here in this case. So same goes with this one, 1 plus 5, 1 plus 8 equals 9. You can just pause this one and just calculate yourself, right? So just in this case, this is considered I, this is nothing but j. Here we are doing I into j. First will be I, this one 2 into 6 18. Next we will get 0001118. So you can just check for the same thing for the other boxes as well. So at the final step, we get here I into j, or num1 into num2 in the DP table, we get this one. So just give me a second here. So yeah, we get this one 056088. This one we have to return the final one. Here what we have got, this one in the DP table, I into j, or num1 into num2. This one we are returning as output by removing the leading 0. We will remove all the leading zeros. Here in this case we have only one leading 0 here. So we will remove this one and we will return this one, the second half 56088 as output. So that is the output we need to get. This is just the DP index, DP of 58. This is just the nothing but the resulting DP. So this one, just keep this in mind, but this is the main thing, I, j and I into j. You can just pause this one and you can calculate yourself step by step, right? This one will be 56088. So 056088 we have got. We will remove the leading 0 and we will return 56088 as output in this case. You can clearly see here in the step 4, or the final result, convert the DP array into the string and remove the leading 0. We will convert the DP array into the string. In this case we will convert this one to 56088. So how we got this one? We are by removing the leading zeros. We will convert the array into string by removing the leading 0. We got 056088, right? Here you can clearly see 056088. The final one, we will return only 56088 in this case, right? So this is the output that we got. So the final result will be this one itself, right? So I hope the approach is completely clear. In this case, let's move on with the edge cases, right? So let's move on with the edge cases. So that will be the approach that we'll be going with, the approach that we considered, right? Step by step, by considering the example 2. So that will be the approach. So just keep that in mind while we articulate the thought process, the same thought process in the form of code. It will be very handy. So we will next, after discussing the edge cases, we have to articulate that one in the form of code itself, right? Finally, so now let's discuss the edge cases step by step. First one, multiplication with 0. Here in this case, 0 into 9876, 0 into anything, it will be 0 itself, right? So this is fine. The second example, the second edge case we are going with here is single digit multiplication. Here 3 into 7 we have to go with. So in this case it would be 21, right? So this has to be in the form of string. So this is fine. So the third edge case here we have to consider here as numbers with different lengths. 99 into 999, 99 into 999, this will be 98901 on this case. 98901 on this case. This is for numbers with different lengths, right? So the final one here is multiplication of two large numbers, nothing but here 999, 999, 999, 999. This will be 9, 9, 8. This will be, you can just make use of the calculator, man, for this one. Yeah, this one will be 1. This will be the output basically. So these are the 4 edge cases that we need to consider here. The first edge case that we are going with here is multiplication with 0. The second edge case that we went with here is single digit multiplication. The third edge case that we went with here is numbers with different lengths. The fourth edge case that we went with here is multiplication of two large numbers, right? So I hope all the 4 edge cases are clear here. Let's go with the code implementation, right? So let's start writing the code. I hope all the edge cases as well as the approach that we discussed is completely clear. Now let's start writing the code here. The first edge case, so here the edge case that we considered, if any number is 0, then the result is quite obviously 0, right? So that one let's write in the form of code here. Let's make use of the simple if condition here. Just give me a second. Yeah, if we have num1 and num2, right? Num1 equals, we are going with strings, so 0, or num2, this is equal to 0, then in that case we have to return 0, right? This is fine. So the step 1, the main step, the step one here. Let's start with the step one here. Let's create an array to store the result. So we are going with the dp, right? So here let me consider dp equals array of num1 dot length plus num2 dot length, and this one, let's fill this one with 0. This is fine. This is step one. The next step here is, or the second step here is, we will traverse num1 from right to left. So we saw this one during the approach, right? We were traversing num1 from right to left. So how can I write that one in the form of code? For loop here, reverse iteration here. This one will be I equals num1 dot length minus 1. Here in this case, I greater than or equal to 0. This one will be I minus minus. So this is fine. The next step here is, we have to traverse the num2 from right to left. We have to traverse the num2 from right to left, right? So we were traversing num1 from right to left. Now we are traversing num2 from right to left. We will just consider one more variable here. I'll just consider j here. This one will be num2 dot length minus 1. Here same thing, j greater than or equal to 0. Decrement the j here. So this is fine. So the next step here is, we have to multiply the current digits. So when I say we have to multiply the current digits, let's directly give here, let multiplication, I'll just take mul here. This one will be num1 of I here into num2 of j here. This is fine. Num1 of I into num2 of j here. I hope this is clear. We are just multiplying the current digits. So the final step here is, we have to add the existing sum to the position. We have to add the existing sum in the position, sorry. So here this step we can articulate in this way, in the form of code in this way. I can just write here in this way. Let sum equals dp of I plus j plus 1, this one plus multiplication, this variable I'm considering, mul I have considered right here, multiplication, this one. This is fine. We are adding the existing sum in the position. So the next step here is, we have to store the last digit at the current position. This is very important. We have to store the last digit at the current position. This one will be dp of I plus j plus 1 equals sum module 10. This is fine. And this one will be dp of I plus j here. This is fine, equals dp of I plus j, this one math.floor of sum by 10. So math.floor, or you can just make use of the double tilde operator as well. This works, right? This is faster than math.floor. So, or you can just make use of the right shift operator. You can make use of anything that works basically. In this case, I'll be making use of double tilde operator, right? So I hope this is clear. First, this one, line number 11, here what we are doing, we are just storing the last digit at the current position. Here in the line number 12, we are making use of the carry, or we have to carry the remaining part to the left, right? So that's what we are doing here in this case, right? So the final step here is, we have to convert the dp array back to the string, and we have to remove the leading zeros, if you remember the approach, right? So we had the we considered this one second example, and we had the leading zero. We removed that one. First we converted the dp array back to the string, and finally we removed the leading zeros. Then we got this output 56088, right? So for that one, how can we write? So here we will just return dp.join. We'll convert the array back to the string here. So this will be string. This is fine, and I'll just go with the replace. This is just, I'll just go with a regular expression here, right? So here this will be 0 plus slash, this one will be string. This is fine. So I hope this is completely clear. Let me format this one once, and let me hit the run button. So here yeah, you can clearly see here the sample test cases are getting passed here. So let me quickly hit the submit button. So here we are getting the wrong answer, right? So in this case output we are getting 0, but we need to get here within the strings. So let's see, somewhere we have done the mistake. Let's so yeah, this is the mistake right here. If num1 equals 0 or num2 equals 0, we have to return 0 in the strings. So I have just given this one in the number format. So let me make this one to string and let me hit the run button again. So here you can clearly see the sample test cases are getting accepted again. So let me hit the submit button. I hope this works now. So you can clearly see here all the test cases are getting passed here. Means the code works absolutely correct on this case, right? So here let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is digit by digit multiplication, right? So what is the time complexity here? Overall time complexity would be big O of m into n, right? So the overall time complexity would be big O of m into n, where m and n are the lengths of num1 and num2. So we know here m and n are nothing but lengths of num1 and num2, num1 dot length and num2 dot length, right? So here what would be the space complexity? Space complexity would be here in this case, it would be big O of m plus n here, right? It would be big O of m plus n because we have to store the intermediate results in the DP array. We have to store the intermediate results in the DP array. We are storing it, right? So that is the reason it will be big of m plus n in this case. So overall time complexity would be big of m into n, and the space complexity would be big of m plus n, right? So I hope this is completely clear. I hope the solution or the code that we have written is completely clear as well, right? So for now, this is it. Thanks for watching, guys.